Remember, he's just an interconnect at this stage. His job is just layer 3 from this distribution layer over to there. So for that reason, I don't really care about ACLs. I don't care about QoS or NetFlow or any of these kind of things, right? Keep it simple, stupid for the basic L3 core, okay? That's the box at the top. Now compare that to an interconnect, right? Now this is the box, the fourth tier that I talked about. This is really about scale. Like I said, your IT department's responsible for multiple buildings, multiple sites, whatever word you use, and I need to connect this location to this other location, right? That is the goal of the interconnect. Now, even at this particular stage, it's about separation of responsibility, separation of load, reducing fault domains. I hope everyone heard these phrases before. But he's still, in his nature, an L3 routed device, right? So that's what I'm trying to say is, like, surprise, not very much has changed. I'm probably still running a standard IGP routing protocol. It's just aggregating the routes from these different sites, these different locations. And, there tends to be more physical links. This actually isn't something in the slides, but I'll connect it back to the cabling thing. That cheap box, you need to be thinking port density, right? How many physical ports are going to be required to pull this off, okay? Yeah. Well, you can use, his question is, should I use BGP on that, correct? Correct. So okay, I understand. He's asking, can you use BGP for this interconnect layer? Absolutely. So it is very common to use, and this is also not a protocol session, but BGP has interior BGP, and it has internal, and it has external. So it has become increasingly common and popular to use IBGP like an IGP, like an interior gateway protocol. So and I'm going to talk about this actually when I get to EVPN, so it's a good point. You essentially have a single protocol, a protocol family between your external routing and your internal routing. But it is absolutely an option point. Which in a way kind of actually gets me to this next slide. So this is what I was talking about, the so-called edge, right? Now, you'll notice from a diagram perspective, remember I said I use a similar format on purpose. I want the slide to immediately be obvious to you. Same picture. What I did was I added some little rainbowy colors. It's not because he's happy. This is the universal symbol for VRFs. Okay? Yeah. I got a couple laughs about that. So what I'm trying to convey is when we go from basic BGP in the global routing table, meaning a single address space, to now a multi-protocol environment with perhaps many different routing spaces in the form of virtual routing and forwarding instances. Okay. But then think about that. Maybe I had 10,000 routes, or I had 50,000 routes in this drawing, right? But I need to multiply those 10,000 routes or those 50,000 routes times 100 VRFs, 1,000 VRFs. Now I need to choose the box that has millions of routes, okay? And he needs to be able to support multi-protocol BGP. We're going to talk about MPLS and EVPN and these kind of things in a bit. The other thing is he's talking to other areas. So now I am the edge, I'm the perimeter, right? It is now my responsibility to provide security, quality of service, and maybe that's a slow WAN link. Like, it's all 100 gig over here, but he's talking to this crappy 1 gig, 10 gig router or firewall. Guess what that means? Big QoS. And you better know how to do QoS, okay? But you get the point. This box, if he's operating in an edge role, needs to have very high scale and very complex feature capability, okay? And it's, again, like, should I break it out? Should I collapse it? That kind of thing. Okay. And pretty straightforward, right? A couple of variations. Here's the baseline. Here's the things that change for those variations, okay? Do the same thing on distribution. First one is a super generic baseline distribution. Now, you remember in the when I was showing you that WoW slide with all the features, and I was saying, layer 2 down to the access layer, and layer 3 up to the core layer. Okay, so that's kind of what it's saying here in the middle. Another thing I should have said is about slides. Again, I'm trying not to read the slide to you. I do give alternate names for this, and you'll notice I put collapse core as an alternate name for it. It's really a distribution layer. Okay, you call it whatever you want to call it. It's going to be a distribution that happens to have some core routing function on it. Okay. The important thing here is that he is also doing L2 switching on the downlink, right? Another name that I put on there was aggregation. Okay. Now this is just a pet peeve of mine. Aggregation is a data center term. Distribution is a campus term. They mean the same thing. Don't worry about it. But if you think about it, it's the direction of flow. What do those words mean? And I'm also very big on words. Aggregation means to take many things together, right? And the flow of direction is upwards towards the aggregation. What does distribution mean? It means take something from a centralized point and distribute it down and outward. So it tells you, this box, his job is really about the access. Remember my very first slide? It's about you, me, our phones, the printers, and access points and so forth, right? It's subtle, but it tells you a lot about its behavior, right? And the kind of features it's going to be running, okay? On the feature side, what I'm talking about is things like VLAN trunks, right? You're going to have all your VLANs coming from the access layer. You're going to be doing your VLAN interfaces here, your layer 3 routed interfaces. So you're going to be doing a lot of like security. You're going to be doing a lot of, as in access layer security, access control lists. You may be doing like flow analytics, things like net flow, and so on. And that's why this is often forgotten, but it's actually one of the most important boxes in the network. Okay, how you design your distribution layer will directly affect how your network performs. Okay, like I said, this one's super fast. You can call it a collapse core if you wish. It just means I'm putting core functions on the so-called distribution layer. What's different in the diagram, if you notice, is the top thingy. So it does classify as a two-tier design. The router guy is performing the edge IP routing, but I still need to connect my distribution layer to that router. Right, so whatever protocol that router happens to be doing, this distribution layer switch needs to be doing that as well. Okay, but at the same time, it's really a distribution layer, just a variation. Okay. Now, last but not least, the access layer. You can tell by now I'm following a pattern. Hopefully, everybody's keeping up on it. Now, your basic access layer is truly the user, okay? At the end of the day, we want this box to be super duper simple, okay? Who has non-Cisco access layer switches? It's okay, I'm curious. There's a lot of you. And nobody's like, man. The reason I asked that question is the super duper simple. It's actually very common, and I'm not advocating that, by the way. It's just, a common behavior. Look, our access layer is simple. I'm not going to do a lot here. I'm going to do my complex stuff on the distribution layer. Okay. Things like power over Ethernet, particularly through copper cabling. Okay. One thing I didn't make a point about is at the fiber and copper. Copper tends to be 100 meters, 300 feet for you Americans. Pretty close, actually, like the back of this room. And imagine it's going up the wall and down. So copper tends to be an access layer function, okay? Where fiber is the long distance function. And you see that reflected in the boxes, okay? They call them access boxes because they're mostly made up of copper ports, okay? Modular, fixed, those kind of things. And then it's the counterpart of that distribution layer. He's going to have some VLANs. You're going to put those switch ports into a VLAN, and then you're just going to give it to the distribution layer, okay? Similar with security, it's kind of, most people do, again, like the complex things at the distribution layer, but you can actually do some of these security, QoS, etc., directly on the access switch itself. It's going to be in the layer 2 context. You're looking at MAC addresses, VLANs, those kind of things. Okay? Now, why would you extend this, right? Well, if an access layer is all about ports, physical ports, then by extension, no pun intended, I need more ports, right? I'm also going to talk about this a little bit when I get to the stacking in just a few minutes. But I just need more ports. I need a bigger access. So this seems to be common in like manufacturing, IoT. Anybody doing manufacturing, industrial? Okay. This is very, very common. So you'll see words like IoT, FTTX is fiber to the something, fiber to the desk, fiber to the edge. The whole point is I'm just making my access bigger, okay? But it has the same characteristics as a regular access. Okay, so up to that point, I know that was a lot. Everybody still with me? All right. Now we'll get into just, again, variations. We're going to talk about core distribution access, but now it's about redundancy and high availability, right? So load balancing, convergence, these kind of things. I also try to be pretty quick with these. Each one of these has a summary slide with that awful yellow color. So, the basic ECMP should be straightforward. Its acronym stands for Equal Cost Multipath, okay? If I have different speeds of links, most protocols, including layer 2, will choose the higher speed link and will completely ignore the low speed link, okay? So the operative part of there is equal cost. Let's say I have two 10 gig links, they're equal. So what I should try to do is get, 10 gig on each of them. I get 20 gig, right? And if one fails, it falls over, but that kind of thing, right? So what it's saying, and furthermore, you can do that with just a single cable. Like I can dual connect. I'm connecting to this box, I'm connecting to that box. One link fails, one box fails, it converges, cool. But it's all based on the protocol. So now you're asking OSPF or spanning tree to make that decision for you, right? You're adjusting timers so that OSPF doesn't take so long to actually converge, right? That's the key here. Then you can do ether channels, and ether channel can be mixed with equal cost multipath. So you can tell I used the exact same diagram, I just gave it more links. This is going to come down to money, right? Hopefully everybody knows that. You're asking the boss to give you more cables and more transceivers and whatever. But the thing I want you to remember is the ether channel load balancing. So it is one logical link by the ether channel, but even if the physical cable dies, the load will just converge on the ether channel. It's not about OSPF or anything. It's about ether channel convergence, ether channel load balancing, okay? And then lastly, stackwise or virtual clusters, virtual switches. These are just words, okay? Now the difference here is the boxes. If you looked at the